So yesterday I was discussed definition of lattice energy. So lattice energy is mainly calculated the sum of attractive force energy as well as repulsive force energy. So attractive energy by considering crystal, ionic crystal. So Mendelov constant for 1 mole of ion. So this is what attractive energy equals to N0 into A into plus Z minus Z into E square by R, where N0 equals to Avogadro number, A equals to Mendelov constant, plus Z equals to atomic number of cation, minus Z equals to atomic number of anion equals to charge of electron, R equals to distance. So where R equals to what is that? Mendelov constant, then repulsive force equals to N0 into B by Rn, where N equals to Born constant, B equals to repulsion constant, R equals to what? Distance. So therefore U equals to so this is attractive force, this is which one? Repulsive force. By the summation of these two always gives which one? Lattice energy. Next one, U is directly proportional to charge, is directly proportional to square of charge and radius or distance, that is cation plus radius of cation and radius of which one? Anion. Now lattice energy, if lattice energy is more for ionic crystal, ionic strength increases. If ionic strength increases or lattice energy increases, solubility what happened? Decreases. Which decreases? Solubility decreases. Now if lattice energy is more, ionic strength is also more. Ionic strength is also what happened? More. When ionic strength increases, when ionic strength increase as increase of melting point of ionic crystal. Melting point of which one? Ionic crystal. Melting point of which one? Ionic crystal. Now if lattice energy is inversely proportional to hydration energy. Hydration energy means when a ionic crystal dissolve in water, what amount of energy is released? The amount of energy released when ionic crystal dissolve in water known as hydration energy. So lattice energy is inversely proportional to solubility. Lattice energy is inversely proportional to which one? Solubility, or directly proportional. Lattice energy directly proportional to which one? Hydration energy. If hydration energy is more, okay, then if LE, lattice energy increases, LE increases, electrolytic nature decreases. Electrolytic, if lattice energy increases, electrolytic nature decreases. Electrolytic nature, what happened? Decreases. Because when lattice energy increases, what happened? Solubility decreases. When solubility decreases, number of ions are formed very less in aqueous state. So therefore, electrolytic nature is also depends on what? Number of ions in aqueous solution. Number of ions in aqueous solution. So therefore, the number of ions are decreased if lattice energy increases. So that is the reason why electrolytic nature decreases. Okay. Which of the following one question here. Which of the following has high lattice energy? Lattice energy, first one is lithium chloride. First option A is lithium chloride, B is sodium chloride, C is potassium chloride, D is cesium chloride. Now, high lattice energy, if the smaller size of cation, lattice energy, what happened? Increases. So that is the reason why the highest lattice energy containing is which one? Lithium chloride. Which chloride? Lithium chloride. Okay, so this about which one? Lattice energy. The next one, Born-Haber cycle. Born-Haber cycle. Calculation of lattice energy. Calculation of which one? Lattice energy, represented by which one? U. So by using Born-Haber cycle, lattice energy is calculated. Now, Born-Haber cycle is always works on the basis of a thermodynamic law known as Hess law. Okay, so based on Hess law, if the chemical reaction takes place in one steps or multi steps, what amount of energy is released? This energy released is always what? Equals to sum of the energies of all the terms. Sum of the energies of which one? All the terms. Okay. Thermodynamic law, thermodynamic first law, that is Hess law is applicable here. Hess law is applicable here. Which law is applicable? Hess law is applicable here. Example, calculation of lattice energy of sodium chloride crystal. Sodium chloride crystal. Sodium chloride crystal. Number one, sodium solid plus half mole of Cl2 gas, to form sodium chloride solid, and delta H is equal to, here is which one? Negative, that is exothermic process. Exothermic process. So here delta H equals to heat of reaction. Delta H equals to which one? Heat of reaction. So Barnard cycle mainly works on the basis of Hess law. If energy is released in one step or multi-step, it is always equals to the sum of energies of actual energy. So that is the reason why here delta H equals to heat of reaction. Second one is sublimation of sodium. Sublimation of sodium. This is A. First one is sublimation of sodium. Sublimation means solid directly converts into its vapor without forming any liquid. Solid directly converts into which one? Its vapor. So therefore sodium solid directly converts into which one? Sodium gas. During this particular process, in order to sublimize, some amount of energy is supplied towards which direction? Reactant side. So that is the reason why here delta S equals to delta H2 equals to delta H1 equals to here positive, that is plus S. Heat of sublimation. This is known as what? Heat of sublimation. Heat of which one? Sublimation. The first step. Second step, B, ionization of sodium. Second one is ionization of sodium. Ionization of sodium. Now, after the formation of gas, While supplying some amount of energy towards gaseous atom, now it liberates which one? An electron, that is sodium plus, and liberate one electron. Liberate what? One electron. This is known as, it is also which process? Endothermic process. So therefore delta H equals to plus I. Plus I. What is that? Plus I. This is the second one. Okay. Third one is dissociation of Cl2 molecule. First, sodium solid converts into vapor in sublimation process. This gas liberates one electron, converts into which one? An ion. Then B is over. Then C is dissociation of Cl2 molecule. Dissociation of which one? Cl2 molecule. In order to dissociate, we can supply some amount of energy towards reactant side. So therefore chlorine molecule dissociate into chlorine atom. Which atom? Chlorine atom. Which atom? Chlorine atom. Here is how many moles? If you are taking half mole. Half mole of Cl2 gas converts into which gas? Chlorine gas. Here some amount of energy is utilized towards this one. That is delta H3 equals to 1 by 2 dE. This is dE means what? Dissociation energy. Which energy? Dissociation energy. dE means what? Dissociation energy. Then D is ionization of chlorine atom. Ionization of chlorine atom. Now this gaseous state chlorine atom attract an electron from sodium metal. Now it converts into which one? It converts into which one? Cl minus gas. Now this is delta H4. Delta H4. So therefore delta H4 equals to, here some amount of energy is released. Due to the addition of an electron, some amount of energy is what happened? Released. So therefore this is minus Ea, known as electron affinity. Electron affinity. Now the final step is formation of sodium chloride crystal. The formation of sodium chloride crystal, that is Na plus, it should be in gaseous state, Cl minus in gaseous state to form sodium chloride. Due to formation of this particular step, okay, some amount of energy, this is delta H5 equals to minus U, means these two are what? Exothermic process, remaining process are what? Endothermic process. So what amount of energy is released or what amount of energy is absorbed, it is always equals to total energy of a particular process. That particular law is known as what? Hess law. Which law? Hess law. So as per Hess law, delta H1 equals to delta H, heat of reaction equals to delta H1 plus delta H2 plus delta H3 plus delta H4 plus delta H5. So therefore Q equals to heat of reaction equals to sublimation energy plus ionization energy plus 1/2 dissociation energy, 1/2 dissociation energy plus electron affinity plus U. U means lattice energy. H1, H2, H3, H4, H5. This is sublimation energy, ionization energy, dissociation energy. These are which one? Endothermic process. These two are which one? Exothermic process. So therefore summation of energy of all the forms always equals to heat of a reaction or total heat. Total which one? Heat. So therefore U equals to lattice energy equals to Q minus sublimation energy, ionization energy, 1/2 dissociation energy plus electron affinity. Which one? Electron affinity. So by using this particular principle, we can calculate which one? Lattice energy. This particular cycle is known as what? Born-Haber cycle. So sublimation of sodium metal, ionization of sodium metal, dissociation of chlorine molecule, then ionization of chlorine and formation of which one? Sodium chloride crystal. So as per Hess law, the sum of all the energies of all the process always equals to total heat change. So this is the Hess law. So therefore Q equals to heat of reaction, okay, or heat absorbed or heat released, okay, sublimation energy, ionization energy, dissociation energy, electron affinity and what? Lattice energy. So therefore lattice energy equals to, okay, heat energy minus sublimation energy, ionization energy, dissociation energy and electron affinity. What is that? Electron affinity.